Welcome, welcome. So, this is Mech School. So, this morning I'm going to talk about 3D printing. I've been printing with this machine since I got it a little less than a year ago. And only recently would I say I've started to kind of get good at it. A lot of the time I find myself just being lazy and not treating my prints, not preparing them as well as I should. And a big part of that is breaking them into much smaller elements so that I can put them back together later, which is just a pain in the butt because I don't like dealing with little small pieces, and I'm printing a lot of gaming miniatures. But if I want good prints, that's what I have to do. Real quick, this is Thingiverse. On here, you can find tons and tons of free stuff. Like I'll just type in, Battle Tech. And bam, all this stuff free. Look at it. Look at it all. Let's say you're not into Battletech. You're like Dungeons and Dragons. Boom. Dungeons and Dragons. Maybe you like you're one of these Warhammer guys. Boom, Warhammer. It's all there. Tons of stuff. There's Fallout. There's any kind of tabletop thing you can think of. There's just files for it on Thingiverse. And then there's useful stuff as well. Lots and lots of good stuff. I've got my things on here. I've got the locust that I'm going to work with today. A couple other things. Some of it's files that I got from other people. Someone else maybe pulled it out of MechWarrior Online or whatever, and then I've kind of made my own modifications to it. It's kind of cool just to go check it out. Even if you're not printing and you just want to see some cool art that people have made, it's pretty cool. If you want to, I'm pretty sure there's a link around there somewhere where you can find printing services, and you can get people to print the stuff for you if you don't have a printer, which isn't bad because they're going to send you a decent print, and you're not going to have to fool around with with this nonsense. So that's not a bad deal at all. All right. So over here in Tinkercad, and another thing, the only kind of paid thing I'm using is the printer and the resin, and we'll talk about those in a little bit. But Tinkercad, which is where I've done most of my designing, Tinkercad is free. Blender is free. Meshmixer, which I'm going to use later, is free. So it's all it's pretty inexpensive to kind of dip your toes in this as a hobby and get into it. So I want to talk about printing before I get into that. So here I have my my locust, and it's broken up into different pieces so I can make it easier to print. And we'll talk about the printer and kind of explain why. So this is an Anycubic Photon. I picked this up on Amazon. It's not that expensive, and it does a pretty good job. This is a DLP printer, which is digital light processing. So inside, I've got a print bed, and the print bed is gonna ride up and down on this screw. At the bottom of the screw is a stepper motor. So there's one stepper motor in the Photon, and it's right down there. And this is my vat. This is where I'll put the resin when it's time. You should be able to see it right here. There's a screen, and it's very similar to my phone. Think of it that way. It's almost the same damn size. So below that screen, there's a UV light source, and the screen will block out UV for the areas where it's not going to print. And then the bed's going to come down. It'll be dipped inside the vat. And then that screen will print a layer. And that layer can be less than a quarter of a millimeter. We'll get into that stuff later when we do the slicing. But suffice to say, it's going to slowly dip into the resin, print a layer, dip into the resin, print a layer, up and down, and slowly build up from the plate. So your print's going to come out upside down on this build plate. On the resin vat, there's a piece of plastic here that's called FEP, and it's just clear plastic, and it gets a little worn over time. It's not the strongest stuff in the world. I haven't had a break myself, but I have. This is my second piece of FEP. I don't wash it anymore. The first piece of FEP I had, I would clean it in between resins with isopropyl alcohol and paper towels, and the paper towels are kind of naturally abrasive, and they scratched it up, and it just got really foggy. So eventually, I don't clean it out. I use a scraper and I scrape my resin out, and that's it. I just put new resin in on top of it, and it's lasted me a while. This way, it stayed in pretty good condition. One thing I didn't know and wasn't doing was the maintenance on this thing. So the screw that the build plate mechanism rides on needs to be greased, and I wasn't greasing it, and it started really affecting my prints. It started making noise, and that's when I got concerned and started searching for a solution online as to what was going on. You can see this silver rail back here. There's some wheels on the back of this piece. So this piece is solid. It doesn't wiggle. It doesn't move. The screw turns, and that causes this to ride up and down on the rail so that the build plate can travel. But it keeps it pretty steady and solid. If it wiggled, it just wouldn't work. But that's a problem some people have, is with that screw. That's kind of the basics of that. The three kind of most basic 3D printings are SLA, DLP, and FDM. Again, this is DLP, digital light processing. The one most people have seen and are familiar with is FDM, which is fused deposition modeling. So that's when you've got the big spool of filament, and I'll call it, it's not really plastic, it is plastic. And the filament gets pulled through an extruder and heated up on a hot end and squirted out a little nozzle. And then sometimes the bed moves, sometimes the arm moves. But you've got an X, Y, and a Z. And as it extrudes the filament, the melted filament, it draws the layers. So it's a little slower, and that method doesn't have the ability to get the extremely fine layer height that you get on DLP and SLA. That said, note the size of my print bed. Like this is Monicure 3D Rapid. This is a gray resin. 4 bottles of this, and I can buy a new printer. It's expensive. It turns out great. I get great results, but this is costly. And there's lots of brands, and you shop around. This is Anycubic. This came with the printer. This is Monoprice. And this stuff's okay. Just to give an example, here's a list there's an Anycubic Photon Facebook group. That's the great thing about 3D printing. There are Facebook groups galore, and the people are relatively invested and excited about being part of them. And there's a lot of great information out there. There's lots of great YouTube videos too. So this is just an Excel document that I got from the Anycubic Photon site, not their site, but the Facebook group. And it lists a lot of the common resins and recommended settings and that people have used for those different resins. And they're all a little different. And then real quick, I'll talk about SLA. It's stereolithography. Lithography is printing. Coincidentally enough, when I joined the Navy back in 1996, I joined as a lithographer, and that's just printing. I was using an old AB-Dick offset duplicator. I trained on Heidelberg presses. It was printing. Stereolithography, stereo, printing, so 3D. And that uses lasers. Yeah, so this is a photopolymer, so it's light sensitive. With SLA, very similar to this, you'll have a vat, you'll have a print bed, but instead of just a bulb underneath shooting through a screen, there's a laser that'll actually draw your layer for you, and it's very, very accurate. I think the most popular printer for that is the Form 2, which is awesome. And maybe someday I'll get one. Someday, hopefully. Maybe. I want one. All right. So I've talked about the printing a bit. We're gonna scale up this model. So there's a couple things I want to keep in mind when I scale this up. There's some physics that come into play inside the printer that we want to have on our side, not against us. And a lot of that comes with suction. So what I wanted to do was like some cheesy high school science teacher experiments. This is a tile coaster. It's kind of a little bit weighty. I've got a coffee cup here. I'm not going to use my real coffee because that's too important. But I'm going to put a little bit of water, just water, not even sticky, viscous resin. Just a couple drops of water on my tile coaster. Just so it's a little moist. Some people hate that word. And I can, it's not working now. It worked earlier. I can make the coffee cup stick to the coaster. It's flat. They're both pretty flat. Now it's not doing it. That's embarrassing. I was all prepared and stuff. Like a high school teacher. I'm not one. Just so we're clear. Because F that. That sucks. Have you ever put a cup down on a coaster and when you pick up the cup, the coaster comes with it? That's the point I'm trying to get to. There is a vacuum that gets created between the two and a little seal so that when you lift up on the cup, the coaster comes with it and you gotta separate them. So imagine the print bed coming down into our vat of resin, which is very sticky and kind of gross and gets everywhere. It comes down to almost touching, a quarter of a millimeter or less. 0.025 is as low as I'll go. So we're talking, a small fraction of a millimeter distance submerged, and then the actual print piece is in contact with the FEP and in contact with the build plate. So if there's a vacuum created, when the build plate tries to come up, it's going to pull on the FEP. And in most cases, ideally, it separates. But we want to reduce that amount of force between them so that when the build plate comes up, we don't want our piece trying to stick to the FEP because that's going to make it want to either pull off the build plate or pull away from the supports that we've created. And we want to minimize that as much as possible. Experiment number 2. So one thing we'll do to alleviate how much surface is touching the FEP to relieve that suction is to hollow out the print when we've got a reasonably large print. But when we hollow out the print, what we end up doing is creating a different type of vacuum. So imagine this is our vat, and it's just water with food coloring. We'll pretend that's our resin. All right, let's put this down for a second. Let's say this is our hollow print. It's going to start here at the plate, right, and slowly build its way up. And each time the plate's going to come up and come back down a little bit to allow resin to get in between the bottom of the print and the FEP. So it's got to come up for the resin to come back in and then come back down. So if it's hollow and it's doing this nonsense, slowly building, eventually resin will get trapped inside, so that when you lift up, it creates that vacuum, right? If this was deeper, I could do a better job. So it creates a vacuum and it's pulling the resin up. Did you see it kind of pop when the seal finally breaks? So again, you're creating a vacuum and suction that could pull the piece completely off the build plate, or just rip it off of the supports. So what we'll do is create a venting hole at the top. And we're just gonna, I'm not gonna do it with a knife, we're gonna do it on the computer. We're gonna create a little hole at the top. So now the air can escape and it doesn't create, it's not a good hole, but you get what I'm saying. So we're going to use those. We're going to keep that in mind when we're hollowing out our piece. Okay. I think that's enough farting around with the printer part. We're going to jump on here. So again, this is Tinkercad. This is a locust that I've created. It's available on Thingiverse. You can probably search locust and find it, or just search for, what am I on there? The Seadaddy, I think. Just Seadaddy. Just go to Thingiverse, do a search. Seadaddy. And boom, all my crap's going to come up. All right. Back over to Tinkercad again. And this is in my browser. This is free software. I'd 100% built this in here. I didn't use anything else. Super intuitive. So what I've done is I've broken this up into the different pieces that I want to print. And I've given myself these little guides here so that it's easy to reassemble it and keep it centered and square in the way I like it. One thing I've done, I've learned that when printing, everything's going to grow a little bit. So this peg, it's going to grow a little bit. That hole is going to shrink a little bit because the inside's going to grow. So if I make this peg the exact same size as that hole, it's not going to fit. I'll have to file it or sand it down, which I can live with. That's okay. But I'd really rather just fit. So I've gone and made that hole a little bigger. I've made that peg a little smaller. You can kind of see it here. Oops. You can see like the hole is bigger than the peg. Now, at very small scale, so the file I put on Thingiverse at 100%, it's not too big, but it's a little big. I made it to be as tall as a standard, like as a medium mech would be. Just kind of talk scale a little bit, right? Here's the old Hunchback that I've been too scared to paint. Someday I will. So I took an MWO file that I got off of Thingiverse, and I made it the same height as the old Mini, because that's how I like to roll. So the Locust, with its long skinny legs and no arms and no abs, just it's a kind of like a torso head and legs. I figured it should be kind of extra tall because it's so damn skinny. So I made it about the same height as this old guy. And when you put these two together, this is just too big. But if I put it next to my MBO Hunchback, it kind of makes a little more sense, right? Because this is just so much bulkier. Such a good design. It's beautiful. So I've deliberately made this 20-ton light mech. I've made it a little tall. This is the size of the file on Thingiverse. And just for shits and giggles, I've printed some at 90%. I haven't got around to putting them together yet. But at 90%, my little peg and my little hole, they line up, and because I've beveled the top of the peg, it can kind of get in there. But if I want it to really go together, I'm gonna have to file it down. So I don't know how well that can be seen, but I got 100%, 90%. But today we're going to do 100%. So the amount of growth that the peg's going to get and the amount of close up on this hole, it's going to be the same at 90%, 100%, and 200 and some percent that we're going to print it at. So I'm hoping, and we'll find out, this is a bit of an experiment, I'm hoping that this peg will fit in this hole at the scale we're going to print it. What is that scale? So we're going to do 1/100. And the kind of general rule kind of referenced online, and I'm happy with, about 8 meters for light mechs, 9 meter tall for medium, 10 meters for heavy, and 11 meters tall for assaults. That's pretty general. Obviously, there's varying weights, varying shapes and sizes, and all kinds of stuff. But for the purposes of this, I'm pretty happy with those sizes. So we're calling this 9 meters tall at 1/100, 90 millimeters. So here's how I do this. I'm gonna group all that crap together. So it's basically one big piece. Bring out a little box. And we'll call that 90 millimeters. Now all I gotta do is grab this piece and I shift and click the height node and drag it up. So there we go. So that's it. It's scaled to a 9 meter tall mech at 1/100, so it's 90 millimeters. So I'm going to grab each individual piece and export it as an STL, put it in a folder, and then we're going to open those up in another program called Meshmixer. I'm going to check the pieces for errors, correct them if I can, and the pieces that are going to be hollowed out, I will hollow out. Likely just the torso, but it could be the legs. The legs have grown quite a bit here. And then I'm also going to split the torso. Hopefully in such a way that I can easily put it back together without too many blemishes. By splitting the torso, I'll make it so that I don't need to put drainage holes, but I also will create faces that print better. So on my build plate, our little upside down print, the light source is here. Whatever is facing the light source as it's building can have amazing, amazing detail. What's facing the plate, however, has to kind of grow from that side up. So unless there's a support directly touching it, it just loses detail. Whatever's facing the plate will have crappier detail or results than what's facing the light source. So the trick is to try to put as much towards the light as possible. So that's part of the purpose of splitting this. And it's a big reason why I've got to break this thing up. I can't just print it as one piece. And I can, and I have, and it's okay, but it's not great. And at this size, it's not going to just fit on the print bed either. So breaking it up helps with that as well. So I like to name my stuff left to right as I'm looking at it. It's just my personal preference. Let's export STL. And we're going to put it in locus 1/100. There we go. And we'll call this left SRM. And the next one, export STL left machine gun. left leg for STL torso, export STL right leg, export STL right machine gun, export STL right SRM. All right. Did I open Meshmixer? Nope. Of course not. Let's get in there. Meshmixer. All right. So we're going to import. Go find that locust 100. Let's just start at the top, the left leg. I'm going to go to analysis, inspector. Got a couple errors, so do auto repair and it fixes them. Done. File, export. Look at this 100. So I'm going to create a new folder and call it correct. And then these, as I fix them, will go into the correct folder. What was this? Left leg, left leg. Know how to do it. Left machine gun. All right, this would be interesting. Inspector, yeah. Gonna auto repair. Cool. Done. File. Export. Left machine gun. So Meshmixer gets a little finicky, especially later when I try to start hollowing things and creating holes. It'll kind of hang up on itself. So I've gotten in the habit of just closing it and reopening it when I import a new thing, and it doesn't hang up as much. Inspector. Cool. So that one doesn't need anything, so we'll just leave it alone. Right leg. Analysis, inspector, auto repair, done, export, right leg, all right. Again, analysis, inspector, auto repair. Make sure I didn't hose anything. Looks fine. Done. File. Export. Right. Machine gun. Savey poo. I'm not going to do the other SRM because it's fine. And then we'll bring in the torso. All right. Now we're going to get interesting. Let's do the analysis. Okay. Do an auto repair. It looks funky in here, but you'll see in a minute. It's pretty much completely fine. Done. All right. So first thing we're going to do is hollow this thing out. So we're going to go to... Yeah. Where's the edit? Here we go. Edit. Hollow. Now it's going to automatically hollow it out at the settings that it's preset with. we're going to change those up. So this is giving the offset distance of 2 millimeters, which is actually kind of thick. So we're going to go down to like 1.48, which I'm pretty happy with. All right. So you can kind of see in there, it's hollowed it out. So the next trick is, what is that? What is that? I don't know what this little dot is over here. That's interesting. A little hex. All right. So we're going to slice this mofricka. So I'm going to accept the hollow and do a plane cut. And what I'm thinking I'm going to do, I'll rotate that to we'll try it. We'll see how it looks at 90. So what this is going to enable me to do is get decent detail on the back of the mech. So it's cutting through. So I think what we're going to do is rotate it a little, move it this way a bit. So the issue with this is it's going to give, no matter what I do, it's going to give me a line. So I think I might try to just line it up on one of these panel lines that I've created. Like that. So it's going to cut through that, and that's mildly problematic. That's the one part of the mech no one's like looking at trying to find the balls on the mech, right? You won't see that from the back. You won't see it from the side. You won't see it from the top. You don't see it from the front. You got to kind of look to find it. So it's just a little escape hatch I made. It's there because it's in the novels. All right. So we're going to create 2 halves. So first we're going to accept that. So we've got this half here, and you can see the hollows. So it's kind of a small piece, but it works. So we're going to File, Export. We'll call that Torso Back. We'll save it. And now here we're going to, I just did an undo. I'm going to hit this little blue arrow and flip it to the other side. So now it'll discard the other half. And here you go. You can see all that hollow space, right? So this back piece will be facing the build plate, and it will build up. So this will face the light, this will face the light, and so the top and front will have kind of the best detail. And as it builds up from back here, all the air can escape right out this hole we've created. So I've solved a couple issues with one slice by doing this. So do an export, call that torso front. Torso front, and save it. And that's it. We're done with Meshmixer. So now we're going to go into my slicer, and what I'm using now is the ChiTu DLP Slicer64, which is an upgrade from the Anycubic Photon Slicer, which is the software I got when I got this machine. And you can just Google that stuff and find it and download it. It's free. So this represents our print area, and this represents the maximum print space. And it's actually not true. It's a little smaller than that, but it's close enough. I've got some settings over here that I pulled from this file. And again, I'm using the Monicure Rapid clear. And there's a couple different recommended settings here. And what I've done is just grab something kind of in the middle of these numbers. And it's been working great, so I'm happy with it. So I'm gonna go File, Open, and we'll go to our locus 100, correct. And we're gonna start with the torso. And I don't know how much of this will actually fit on the printer. It's gonna be a pretty good size. So we gotta rotate it. We gotta rotate it so this piece here is facing this, the print bed. So the best thing you can do is put, if you had a cube, you would print it from a corner, and not a two-side corner, but like on its edge. So like if I was going to print a dice, I wouldn't print it flat. I wouldn't print it on an edge like this. I would print it with a point down. And that's kind of what I want to try to do with all of these. Is point it down. So I'm going to do a reset. I have trouble doing the X and the Y. So I'm going to do 45 there, and then I'll have to start at 320 and see how it looks. I'm going to have to tilt that back a lot. And I think that should be okay. The turret's going to be great because it's a sphere. It's going to print with no problems. The flat edge here facing down isn't going to be great, but it's probably going to get a little bit of filing or sanding and then sandwich, because the leg piece is going to sandwich up against it, so it losing detail won't be the end of my world. All right. I'm going to give this a try the way it is, and we'll see how it goes. And then real quick, I'm going to kind of do the same thing here. I want those vents up though, because that's the piece of detail I'm hoping to save. That didn't work. There we go. I think that'll be okay. Where this is kind of flat right here, that's not real good. I think we'll be all right. So I'm going to come over here to the supports. We'll see what auto support looks like. Sometimes auto support puts just way too much crap on there and puts it in silly places. Not super in love with that, so I'm going to remove supports and just put them in myself. Everything against this edge will be sanded before it's made flush with the other piece. So it's facing down, so it's going to be ugly to start with. So it's going to have to be sanded a little. So this is where I kind of rely on that little bit of growing I talked about before in order to make these two things meet. There's going to be a seam, and I'll have to clean it up, but it'll be fine. So this is kind of interesting. So see this black line that's coming up right now? Imagine that's our layers, okay? So anytime it kind of hops over, see how it hopped over to the turret just there? That becomes an island of its own. So it's going to need its own support. You can see this here. So here's the lowest point on that island, and I'll throw a support down. So there's a decent chance, like with those two supports, if gravity and suction and everything else wasn't a factor, that this print, if these 3 supports could hold onto this, it could print just like that. And each layer would just build up. I think I have an island here. Yeah. Over here, I have to put one. Probably over... Nope. But here, definitely. So let me throw that on. There we go. And I'm just gonna put enough of these on here that the print bed can hold on to the print under pressure. Nope, I don't like that one. All right, and I feel obligated to put some more on here, just so that the bed can hold on to the print. I want to put them where it's going to be easy for me to remove them without creating any kind of blemishes. I don't want to touch that turret. I think it's going to be okay. Technically, right there is an island. I'm going to throw a light support up there. Gosh darn it. Right there. So, what I don't like about that, I wish I could add supports to supports. Is this, so this is a light support, and I have no reason to believe it's going to not wiggle. So I'm going to kind of build out to it. There we go. And let's see, we'll do one more on the thing. Okay. And all that is just to steady up this connection right here. And that these will be easy enough to trim off and clean up, so not too big a deal. Let's put them, the tips of these little vent doodads. Do I need it anywhere else? I think we're kind of okay here. I think. Yeah. Okay. So that's that. That's one thing kind of down. I'm going to turn this. Right there, and let's throw the auto support on this and see what it does. And just kind of All right, see this? None of that will print until it gets to about here, and then that'll start to print here. From that support way over there, it'll start to print. This would be an absolutely failed print. So let's remove those. That was ridiculous. That would be just complete trash if I tried to print it. I don't like how straight up and down that is. So I'm going to try and rotate that. I think it works better for me. Go back to supports. Little island right there. Right there. I think that's gonna work. I don't think I need anything out here. I'm gonna put a couple just in the name of stability. But that should be good. All right, so that's 2. And let's bring in the leg. Oh man, that's huge. It's huge. I'm not going to print that at the same time as these. I'm going to have to do it separate. Let's bring in my gorgeous machine guns. All right. So these have been mildly problematic in printing so far, but they've been so tiny that that's not, or at least shouldn't be too surprising. So as long as I get a good angle, that's not what I want. So I'm going to try and get, nope, 45 and 45. Like that. And we should be okay. All right. And I definitely don't trust the auto support for this. So I'm going to use the line there to find my lowest point. Pop a support on it. Lowest point on here, pop a support. Lowest point on the gun. Pop a support. Shouldn't be too close. That should be okay. That ball right there, I don't think I can just hit the lowest point. We'll see what it draws. Yeah, it's not being kind. So if you can see what happened there, it drew the support from this piece to that piece, which is fine. It's just, it means 2 cuts. It means a little blemish right here. I'm going to delete that. I'm going to try just a light support and see what that gives me. Cool. I like that a little better. And then the ammo belt. This is just going to be a series of light supports. Cool. That worked out kind of well. It's turning out to be a little more support heavy than I'd prefer. Urgh! Those last 2 I added just so I could try and get something to connect to that for stability. Oh well. So that's that. It should be okay. And I'll try this one out. Kind of do the same thing. Go back to medium. If anyone's in chat or anything, I apologize for not paying attention. Kind of in the zone now. Gonna hit kind of a lot of the same stuff. All those lowest points on pieces. So this elbow, it would print, but it would lose a lot without that support there, because there's a smidge of an island. And the belt. So I'm going to get rid of those two lights I just put on there. If I can get just one of them to be connected to that solitary doodad, I'll feel better about it. You son of a bee. Alright. Well, it just doesn't want to be supported. I'm going to put one here. God damn it. Why don't you just do what I want? Okay. Feeling good enough about that. Okay. All right, so those are those pieces. Not the whole mech, but a healthy portion of it. Settings look good, so now I'm going to slice it. And I'm going to put this in a folder on my desktop called, I think it's to print. To print, there we go. And call this Locust 100. Save. So now it's slicing. Slicing is creating all the individual layers that it's going to print, and there's thousands upon thousands of them. So while that's slicing, hey, check this out. This is a MWO Hunchback. Modified it just a smidge. But I printed this. This is 1/100 scale. Same scale as the Locust that we're building. Hollowed it out. It's pretty light. But it's not too bad. I wanted something big because I want to try and do some like extreme weathering and rust with it. So that'll be cool. So it comes out the printer, and it's covered in nasty resin. So it gets dipped into a bucket of isopropyl alcohol. I let it soak a little bit. I get a toothbrush and I scrub it with the isopropyl and try and get all that stuff off. Then I take it down to my kitchen sink and I wash it in warm, hot, soapy water. And I get a different toothbrush and I scrub it again, rinse it off real good. I let it dry a bit, and then it goes into a light box that I have, a UV light box, to finish curing it, and that hardens up the resin. I say light box, but it's a paint can with a long strip of UV LEDs wrapped around the inside of it, and I'll let that go for a little while. Then it gets nice and strong. It's pretty cool. So once this is done slicing, it's going to come up with a number, an estimate on the low side of how long the print is going to actually take. And I'm guessing that's somewhere between 5 and 7 hours on the printer. Ooh. Total estimated print time, 3 hours, 52 minutes. So it's going to go, it'll go a little over 4. It might hit 4.5. That's not too bad. So I've got these. I'm going to get them out of here. And we're going to do our legs. As soon as I find, here we go. One 100, left leg, open file, right leg. All right. So, just from experience from printing the other ones, a lot of that is great. It's at a pretty good angle. The issue I'm going to have is down here at this flat foot. That's going to make me need to tilt this thing. So, we're going to see what it looks like at 45. If I can even fit it, I cannot. So 45 is no good. So that's a little too close to these edges, and I don't think it's going to print that way. So give it a little more. A little more. There we go. That's as close to the edges as I really want to get. And you know what? I should have done that the other way. So we'll go. I decided I wanted the outside of the leg to be facing up, because that should give me a little bit better detail on the outside, which is obviously a bit more visible. So now, decide if I'm going to do that kind of shenanigan. I think I can get away with that. Better if I go the other way. Yeah, let's go that way. Yeah, I think that'll work. And then this one, kind of going to do a pretty similar thing. Let's go. Oops. See if I can get up to 35. Yep. This one, because it's bent, it's shorter. So with this leg, you know what I actually did was I turned it a lot. Like that. And then I'll put it in here, do 180. Yep. Turning it on the Z, that's just a rotate, so not too big a deal. Let's rotate that some more. A little bit of a roll of the dice with the for the edges, but and this should really be and word angle. Let's throw our supports on here and do the auto support, see what we get. All right. So now we've got issues like this support running through the leg, and there's no good way to clean that up ever. That is so close to this that they're going to fuse. And it's just a lot, all these little supports. Every time a support touches a model, it's a blemish. It doesn't matter how you remove it. It means you're going to have to do some correcting to fix it. So remove all support. This is a big piece. I'm going to throw a couple of heavy supports on the bottom of the foot. Definitely do heavy here. If I can get a heavy to fly off of that. Yep. And there. I like it when I can get them to connect up. There we go. So that's nice. I'm going to switch to medium and start hitting the islands on the bottom of the foot. All right. That might be okay. It's always a question, because if I miss an island, it won't print right. I did that on my first print, first broken up print, the 90%. Here. This is the 90% leg. I'm not sure how well you can see it. On this one, the supports didn't hit this toe properly, so that toe didn't print right. I think this is going to be the tallest thing I've ever printed on this machine. Now right here, some of this is going to get cut off. And the supports are okay, and I think the toe's okay, but some of that base plate, some of that print bed there, that's going to get cut off. And that it's okay, it's fine. And I'm just not even going to try and trust the auto support here. So I'll start with my heavy supports, places where I can get it. Switch to medium. Those islands. So up until here, there's a lot going on and not a lot actually supporting it. This isn't, that support's not a content, it's just these. So I think I need, just give ourselves a couple easily removed. There we go. All right. Didn't mean to do that. There. Nice. Okay, we're going to slice this. And that is not where I want it. Desktop to print. Go locust 100 legs. And it's slicing. That's going to be about it. I've got it sliced. I have to change the file extension to Photon because it's a Photon printer. And then I put it in a USB stick that I have here somewhere. Put the USB in the printer and I hit print. And then, you know, I wait. And it's going to take, it'll be tomorrow before this is done. But once it is done, I'll get some pics out on Twitter and throw them up on the old Facebook there. It should look pretty good. It should look really nice at this scale. So, looking forward to it. If you guys have questions, feel free. You can get me in the Twitter. I'm just curious. I want to see what the how much time it says it's going to be. So that's the one thing about DLP. It prints that whole layer at the same time. It doesn't matter if I have like a tiny 1 millimeter wide tube. If it's the same height as this, it's going to take the same print time. 8 hours, 36 minutes. So that's going to go well over 9 hours just on the printer. So what was the other one? I said it was going to be like 4 and change. So 9, 10, 11, 12, 13. For this whole thing, we're looking at like 14 hours of just printing. It's a lot. Hopefully it'll look good though. So, all right, guys, it's been fun. And I will catch you next time. Hey guys, thanks for watching. I hope you liked the video. Please hit like, hit subscribe. I was talking to starting a Patreon page, so if you want to help the channel grow, please visit patreon.com/Seadaddy and let me know in the comments below what you liked, what you didn't like, and what you might want to see next. Feel free to share the video, and I'll see you next time.